Hello students, let's practice a little bit of dimensional analysis and also density. Let's start with this example of copper pellet which has a mass of 0.281, let me just change my pen here, kilogram. What is the mass in grams? So they are asking grams and they give us the unit conversion over here. I could use 1 kilogram per 1000 grams, or I can use 1000 grams, it's 1 kilogram. But look at this, I have kilogram and 1 grams. So if we start with my value 0.281 kilogram, now I'm going to use my unit factor, right? So my unit factor, I need to cut off this and I want my result in grams. So use the unit, please. So 1000 grams per 1 kilogram. So I can cut off this and I will have 281 grams. So what about if I don't remember this and I use opposite? Look at this. If you use opposite, 1 kilogram per 1000 grams. So we're going to divide this by this, and then will be 0.281 times 10 negative 3. And I have a kilogram times kilogram, and then the kilogram square divided by gram. And this is wrong, right? Complete wrong. So pay attention to units, use it. Because you know that if you want to eliminate a unit, you need to divide by the unit by the same unit. So we have 1, okay? So let's go to another example. Just press pause in your video and try to do by yourself the second one, okay? And just read the problem and ask yourself what I have here and what I needed. So I have centimeter and 1 inch. So I will start with this. Grab another color. So I have 326 centimeters, and I know that 2.54 centimeters is 1 inch. I can use that 1 inch is 2.54 centimeter. Which one am I gonna use it? This or this? This, right? Because so I can cut off the centimeter. So it'll be 1 inch divided by 2.54 centimeter. Look at this. I can cut off this and they're gonna have inch. So we divide 326 divided by 2.54 and they're gonna have 128 inches. Pretty easy, right? So it's only practice. So let's practice, okay? So I have another problem here to work with you. A hospital administers for fluid at the rate of 95.0 cubic centimeters per hour. How many liters of this fluid does the patient receive per day? These problems are not made by me. I use the problems by the Revell Introductory Chemistry from Macmillan Learning. Okay. So here they are asking us the volume. So I have a cubic centimeters and I want a liters. How are we going to do this? Can you do this? Just try by yourself. So they are not giving us the units, but they say that we have cubic centimeters per hour. What? Well, okay, cubic centimeter per hour, and I have, so I need and liters per day. Okay, so I know that UN cubic centimeters is equal 1 milliliter. I know that 1000 milliliters is equal 1 liter. So 1000 cubic centimeters is equal 1 liter. And time, I know that 24 hours is equal 1 day, right? So what I have here is 95.0 cubic centimeter by hour, divide by hour. So I know that 1 liter is 1000 cubic centimeter. So I can cut off this, right? And I know that 24 hours, if hours over here, I need hours up there, so I can cut off hours, right? It's 1 day. So my result will be 95 multiplied by 24 divided by 1000. So it will be 2.28 liters per day. Okay? See, I cannot do this because I feel better doing separate. So first you can convert volume and then you convert the time. Whatever you do, you need to have the same answer. Okay? So let's talk about density. Remember that density will be the mass divided by the volume of the same substance or object. Okay? So here says that aluminum has a density of 2.70 grams per cubic centimeters. And also, it asks us what is the mass of block of aluminum if a volume. So they are given a volume. So you don't even need to memorize anything, right? So because you are able to do by yourself just reading and knowing that the density is mass divided by volume. But we have liters over here, and here have cubic centimeters. What I'm gonna do, so I need to convert. I know that 1 cubic centimeter is equal 1 milliliter. So 1000 cubic centimeters is equal 1 liter. So if I have 1.32 liters, if I want to convert to cubic centimeters, I'm gonna use 1000 cubic centimeters for 1 liter. So I can cut off here, and I'm gonna have 1320 cubic centimeter. Good. So now, if I have density is mass divided by volume, so I pass this to there, and so we multiply volume in this side. So this gonna cut with this, and I have mass equal density times volume, right? So mass will be the density. Always use the unit so you don't get confused. And I'm gonna multiply by the volume, 1320 cubic centimeters. So you can cut off, and they're gonna have grams, which is 3560 grams. Good. And we can do one more over here. So now we have object, so they give us the measure of this object, and then we need to calculate the density, and ask also if they will float in water. So that is a lot of question. So what I have over here, so I have object, right? Let's try. I'm a good chemical engineer, but I'm not good at design. Okay, so I have 3 centimeters over here, and I have 2 centimeters over here, right? And I have this, which is 1 centimeters. Okay, so we know the volume is length times width times height, right? So the volume will be 3.0 centimeters times 2.0 centimeters times 1.0 centimeters. So the volume is 6.0 cubic centimeters, right? So now I want to calculate the density. So I have the mass, 7.2 grams, and I have the volume, 6.0 cubic centimeters. So I have 1.2 grams per cubic centimeters. Water is between 0.9998 grams per cubic centimeter. That is the density of water, close to 1. And this is 1.2. So this is more dense than water, right? If this is more dense than water, that will float? No, it will not float in water. Okay? That's it. That's all. I hope you understand. And if you have any question, you know that you can ask me any questions and I will answer you back. Okay? So that's it. That's all.